This video will discuss the solution to question 29. What is a good approximation of the DC gain of the amplifier in figure 2? And then 8 possible answers are given on the dB scale. This here is figure 2. It shows the same two-stage amplifier and all 4 options with different possibilities for the compensation capacitance. However, we are talking about the DC gain here, so this compensation capacitor will behave as an open circuit. So in that case, all of these 4 circuits will behave in the exact same way. We can find the formula for the DC gain on the formula sheet, and it's given as follows. The DC gain is given as the transconductance gain of the first stage multiplied by the output resistance of the first stage, and then that's multiplied by the transconductance gain of the second stage and the output resistance of the second stage. The transconductance gain of the first stage is quite simple to find if we look good at the figure. The small signal is imposed on this terminal here, and that is a PMOS transistor. So that means that we will have a transconductance gain of G.M.P. The output resistance of the first stage can be found if we apply some simple small signal analysis to this differential amplifier. As a result, the output resistance will be equivalent to the resistance of this PMOS transistor in parallel with the resistance of this NMOS transistor. So that is RON in parallel with ROP. The third factor is the transconductance gain of the second stage. You can find it by looking very closely at the figure and seeing that we have a small signal leaving the first stage and then entering the gate of transistor N3 where it is amplified. So the transconductance gain will be caused by N3, and that is GMN. The last factor is a bit more complex because we have these cascode transistors here. These cascode transistors cause the output resistance of each of these branches. If we look closely, we can think of this output as having 2 branches, one moving up and one going down. Each of these branches will have an output resistance which is multiplied by the intrinsic gain of your cascode transistors. We can, for example, say that the output resistance of the lower branch would be the resistance of our Mn3, which is RON, multiplied by the intrinsic gain of our cascode transistor, and that is GMN times RON. And the output resistance of the upper branch will be very similar, like GMP ROP as a factor of this cascode transistor multiplied by the intrinsic resistance of our MP4. And then R2 is those 2 resistances in parallel with each other. So that is RO lower in parallel with RO upper. And if you now fill in the values that are given in this caption, so if you fill in GMP and RON and ROP, that will give you a DC gain of 1904.8. But this is not in the dB scale yet. To do that, we should remember that A0 is a voltage gain, and that means that we should take the 20 log 10 of the linear value, and that is approximately 65.6 decibels. And that is the correct answer.